Every time you tap your card or check your bank balance on your phone or Venmo a friend, you're plugging into this massive, totally invisible system. It's the hidden architecture that holds up our entire financial world. So let's pull back the curtain and see how it's all put together.
Have you ever really thought about that? It's a simple question, right? But the answer is pretty fascinating. It's not literally in your phone, and it's not sitting in a vault at your local bank branch. So where is it? Well, to figure that out, we've got to start with something we all talk about, the cloud.
So here's the plan. We're going to build a kind of digital fortress piece by piece. We'll start with the foundation, which is the cloud. Then we'll build up the walls with cybersecurity. After that, we'll look at the secret codes that protect messages inside. And finally, we'll see how this whole fortress powers the world of modern finance.
All right, first up, the cloud. This is literally the foundation for everything else we're going to talk about. Before we get into firewalls and secret codes, we have to understand where all this financial data is actually stored and managed.
We all use the phrase, right? Oh, just save it to the cloud. But what we're really talking about isn't some fluffy thing in the sky. It's a very real, physical network of powerful computers, or servers, tucked away in data centers all over the world. It's what lets you access your stuff from anywhere, on any device, without jamming up your phone's memory.
And his image here really helps make that idea concrete. You can see these massive server banks. You've got your servidor as Google, your servidor as Apple, all connected through the internet to you and your devices. It's not just one computer. It's this giant global ecosystem of computers all working together as one. That's the cloud.
But of course, it's not perfect. There are trade-offs. On the one hand, it's incredibly convenient, right? Your stuff is automatically backed up, you can get to it from anywhere, and your phone doesn't run out of space. But on the other hand, you're dead in the water without an internet connection. And it opens up some really big questions, like who's actually in control of your data, and how safe is it really?
So, if the cloud is our foundation, we obviously need to build some really, really strong walls to protect it. And that brings us to the next layer of our fortress, cybersecurity.
I mean, think about it. We live so much of our lives online now. Our banking, our jobs, our social lives, it all happens over the internet. And the more of our sensitive, private information we put out there, the more absolutely critical it becomes to lock it down.
Good security really comes down to these 4 key ideas. Let's break them down real quick. First, you have confidentiality. That's basically privacy, making sure only the right people can see your info. Then there's integrity, which means you can trust that your data hasn't been messed with. Third is availability. Pretty simple, right? It means you can actually get to your money and data when you need it. And last, you've got authentication. That's just the system proving that you are who you say you are, with a password or your Face ID.
Okay, so our fortress has its foundation and some thick walls. But what about all the messages being passed around inside that fortress? How do we make sure that even if a spy manages to get past the guards, they can't read our most sensitive secrets?
And this is where it gets really cool. This brings us to the most brilliant layer of our fortress, cryptography. This is literally the art of secret codes, the invisible ink that protects our data.
Back in the day, even incredibly complex codes, like the famous Enigma machine from World War II, could eventually be cracked. And the reason why is that they all had patterns, little quirks that code breakers could exploit. The massive breakthrough came when we figured out how to create encryption with no patterns at all, something truly mathematically random.
The secret sauce behind all modern encryption is a beautiful concept called a one-way function. Think of it like this. I tell you to take 100 steps. Easy to do. But what if I just showed you where I ended up and asked you to figure out exactly how many steps I took to get there? See? It's super easy to go one way, but a nightmare to try and reverse. That's a one-way function. So, let's see how this actually works in practice. It all kicks off with a prime number. In this little example here, you can see primo 17. So we start with the number 17. You can think of that number as the unique blueprint for a secret mathematical maze.
Now, you take that starting number and you perform a bunch of calculations on it, multiplying it again and again. What you end up with is this incredibly complex web-like path. Now here's the key. If you know the starting point and how many steps you took, it's a piece of cake to find out where you landed on the map.
And this quote right here, this is the magic trick. But if you only know the location, it's incredibly difficult to figure out how many steps it took to get there. If all you have is the final answer, trying to work backward to find the original question is basically impossible. That is the one-way function protecting your data.
Of course, your bank isn't using a simple number like 17. The prime numbers used in modern finance are just a little bit bigger. In fact, they are 300 digits long.
Yeah, let that sink in for a second. To crack that code, to reverse that one-way function for a 300-digit prime number, would take the fastest supercomputer on Earth longer than the universe has been around. It's not just difficult. It is, for all practical purposes, impossible. That is the insane power of the math protecting your money.
So, let's bring it all home. How do all these layers, the cloud, the security, these unbreakable codes, all stack up to create the financial system we use every single day?
So there you have it. Our digital fortress is complete. The foundation, the ground it's all built on, is la nube, the cloud. The protective walls surrounding it all, that's your ciberseguridad, or cybersecurity. And the secret messages being passed inside, kept safe from prying eyes, that's cryptographia, or cryptography.
Together, these three layers create that invisible infrastructure that makes everything in fintech possible. But technology never stands still. There are things on the horizon like quantum computing that could, theoretically, pick the locks of our supposedly unbreakable codes, which leaves us with one huge pressing question. What will the financial fortress of tomorrow need to look like?